Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. As was just stated, this video is for students in pre-calculus. It is assumed that you've had a full course in trigonometry. So as I go through this review of trig and kind of remind you of how to do things, I'm not really going to go into a lot of detail. I kind of barrel through this stuff because, well, you've seen it before. If you haven't, if you've landed in pre-calculus or somebody advised you to take pre-calculus without you having a full course of trig, I do have a video series on trigonometry, and you can just find my playlist on trigonometry and start watching that. It's almost a full semester course of trig, so it's a lot longer than what you're going through here, but it's advisable because you won't survive calculus without having a very, very, very strong background in trig. That's a heads up warning. All right, let's do this. The terminal point, P, the point xy, determined by the real number t is given below. Find sine of t, cosine of t, and tangent of t. So this is a very elementary example, right? We know that the sine of t, first of all, we should probably verify that this point is on the unit circle because they didn't tell us that it's on the unit circle. So why don't we just verify that? Let's make sure that it is, because if it's not, then I have to make an adjustment. So this is what the unit circle formula should be. Let's see if it is this. So let's take that x and square it. And let's take that y value and square that. And let's see what it turns into. Well, that's, let's see, 36/49 plus 13 over 49. 36 plus 13 is 49. So yep, definitely this point is on the unit circle. I just wanted to do that because what if it wasn't on the unit circle? Well, then we would have to use the alternative definition of trigonometric functions, which is the sine, instead of being the y value, would be the y value over the radius of our brand new circle, which is not unit. But in this case, it is unit, so I get to do that. So sine of t is the y value. The y value here is root 13 over 7. Likewise, the cosine of t is defined to be the x value of the point, and the x value is negative 6 over 7. And finally, we're asked to find the tangent as well. And the tangent of this number t is going to be the y value over the x value. The y value here being a root 13 over 7. The x value being a negative 6 over 7. Multiplying numerator and denominator by 7, you get negative root 13 over 6. We've been given a real number where it represents a terminal point on the unit circle, and we found the sine, the cosine, and the tangent for that number. Now we're given a bunch of different arc lengths, because remember, right now we're just considering the unit circle argument, but also remember that on a unit circle, the arc length is the same as the angle in radians. The problem is, if you were just learning trig for the first time, which you're not, you wouldn't know what a radian is. So that's kind of a weird thing. But luckily, we do know what radians are, so I'm just going to kind of hand wave here a little bit since you've already had trig. I'm just going to go ahead and write out my special triangles off to the right-hand side. So here are my special triangles. I have the 30 degree, 60 degree, 90 degree triangle. And that's 1, 2, root 3. Although, if you're dealing with the unit circle, you would write it like this. Not my favorite version of it, but whatever. And then you have your other special triangle, which is the 45 degree, 45 degree, 90 degree. 45 degree, 45 degree, 90 degree. And again, if you're on a unit circle, these are the ratios. It's the same ratios if you're off the unit circle. It's just, I would write my triangles slightly differently without all the fractions if we were not talking unit circle trig. Now, we also talked about it last time that the angle of pi over 6 ends up being, the angle of 60 degrees ends up being pi over 3, and the angle of 30 degrees ends up being the angle that gives us the arc of pi over 6. So you could trade these angles out for those arc length equivalents on a unit circle. They're not arc lengths, they're actually angles, but we found out that the arc length and the angle are the same when you're dealing with a unit circle. But the angle is in a special measurement system that we have not really truthfully defined yet. So all that being said, compute the value of the following trig functions. The sine of 7 pi over 3. Well, if you were to quickly scratch out an angle of 7 pi over 3, let's see. Here is 3 pi over 3 right there. And we keep rotating until we get to 6 pi over 3. And then we go a little bit more. So this is a full angle of 7 pi over 3. And we talked last time about a reference number. Not last time, but in one of our previous videos, we talked about reference numbers. The reference number here is pi over 3. And so I can just say, well, that angle sine of, or that arc length, I guess you could call it, the sine of 7 pi over 3 is the same thing as considering possibly the sine of pi over 3, the reference number. It's not always the same, but it's close. So sine of regular old pi over 3 is what we're going to consider. However, you do want to consider the fact that you're in quadrant 1 here. And looking at my pi over 3, let's see, pi over 3, the x value would be 1/2, because this is, if you're looking at this pi over 3 right here as your angle, then the x value is right here, 1/2. So I'll write that in. And the y value would be the y value here, root 3 over 2. So I'll do that. Or you could use right triangle trig, which is much better. But anyway, so the sine, which is the y value, is root 3 over 2. I don't need much else with that. And now we're asked for the cosecant of that same exact arc length or angle, arc length in the unit circle or angle outside. And that's just going to be the reciprocal of the sine. So that's going to be 2 over root 3. And then the cotangent, well, that is the x value over the y value. The x value here is 1/2. The y value is root 3 over 2. Multiply top and bottom by 2, and you get 1 over root 3. Very, very nice, quick problem. And then I have these, what I call axial angles. Axial angles are angles that land on an axis. So if you consider, I'll draw it out here, that this is 1 pi, 2 pi, 3 pi, 4 pi. Basically, even pi exists on the positive x-axis and odd pi exists on the negative x-axis. Then you could start just looking at, well, is that an odd number times pi, or is it an even number times pi? And it's an odd number times pi, so we're going to eventually land right here at the point -1, 0. The sine is the y value, so that's going to be 0. Cosine of 14 pi. Well, 14 pi is going to land on the positive x-axis at 1, 0. And remember, cosine is the x value, so it's going to be 1. And tangent of a 15 pi. 15 pi lands again on the negative x-axis, and it's going to be the y value over the x value, or 0. 0 over -1, but still 0. So that's how you do that. Obviously, there are some values you can't work with. So if I had g here and I said what's tangent of I don't care. It doesn't really matter. Let's say 17 pi over 2. Okay. Well, 1 pi over 2 is right there. 2 pi over 2. 3 pi over 2. 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. And that's a ridiculous way of doing that, but I'm just showcasing this. So the x value is 0, the y value is 1. But remember, tangent's the y over the x, and the x value is 0, so tangent would be undefined. And we could have just used the fact that we stated in the previous video, the domain of the tangent includes all numbers except for any integer multiple of pi over 2. Well, pi over 2 plus any integer multiple of pi. So that is pi over 2 plus 16 sets of pi over 2. So that is why that is undefined. All right. So at this point, we have actually just covered very briefly, just kind of evaluating these using the unit circle definition. In the next video, we'll review some fundamental trig identities, just the basic ones. And then after that, we'll start heading into the right triangle definitions.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. Don't whine. Just